Hey all, we have been talking for the past couple weeks about polynomial expressions. Multiple terms with different exponents, no equal sign, that's what makes them expressions. And now we're going to talk about quadratic functions. So it's basically a polynomial that we turn into an equation. And when we have it to the second power, when we have one term to the second power, we call that quadratic. And we call them functions because we use this notation. We're used to seeing equations where we have a y by itself, and then we have an x. Now we're going to have a couple x's. We're going to have one that's to the second power, one that's to the first power, and then we have here, this is called a constant because there's no x. And we're going to have lots of variations of this, but it's quadratic because we have the biggest exponent is 2. And so usually we could plug numbers in for x and it could tell us what y is, and when we get ordered pairs, x, y. So now that we are sort of like moving up in math, we can sort of write in a different notation. It's called function notation. And that's what this f with the x is. This is read f of x. F standing for function. And it's just a different way to say y. This isn't f times x. This is one thing together. It's just another way to represent y. And we're saying that this thing is a function of x. And so we could plug x's into our quadratic and we could get results out, and we would still get xy's. We would get points that we could put on our coordinate plane. It's just a different way to write it, a different notation. So I don't want to get too hung up on that right now. What we're going to do is we're going to graph these things, and we're going to use the Desmos calculator. And so if you don't have that pulled up right now, you should pause the video and you should go pull up the Desmos calculator so you can follow along with me. And then you should press play, and we're going to go ahead and we're going to graph some of these. I'm going to graph a few. I'm going to have you graph one. If ever you have a question throughout this, like why did I do this? Why did I do that? Just write that down in your notebook so that you don't forget to ask me. If you don't write it down, there's a big chance you forget, and then you don't get your question answered, and I really want to answer your question. So pause it, open Desmos, and we'll get going. Okay, so hopefully you opened up Desmos, and what I'm going to do to graph these is I'm going to put these into Desmos, and then we can pick out some points so we can put them, we can sketch them on the graph. They're not going to look perfect, but we're going to do the best we can. So I have Desmos. So I'm going to look at one question at a time here. So I want to hit this plus button up here, and I'm going to pick this f of x, put in a new function. Oh, it didn't work. Oh. So here's what I'm going to do. I can actually type in f parentheses x. There's my f of x equals, and then I can type in my equation. Negative x squared, I get the squared by doing that a to the second power, minus 4x minus 1. And there I have what my quadratic function should look like. It's not a straight line anymore. We have a squared now. It makes it this curve. And so I can find some points on my curve that will help me sketch it. So I have one right here at -2, +3. So I'm going to go over here on my graph and put a point at -2, +3. And then I can find some more. It looks like I have one point here at 1, -5. Well, that's not, I don't have room for that. Let's see if I can find some more. Oh, I have one here at 0, -1. That's a better one. And then I'm going to find one more point, -4, -1. And then I could just do the best job I can at trying to make that curve. And the graph that we have right now, Over here is sort of a zoomed in version of this graph. So it's going to look a little different. And I'll put some arrows because this thing goes on forever. And that's it. It doesn't have to look perfect. We get the idea of what it looks like. So let me do another one. Again, I can just type in f parentheses x parentheses with my equal sign, and I can type in x squared, use this for the squared, plus 4x plus 3. Notice how this one curves the other way because I have a positive number in front of my x squared now. We'll talk more about that as we get into this. I'm going to zoom in because that's how our graph is over here on the right. And so we can sketch this. And so it looks like I have, again, a point here at -2, -1. So over here, I can find some other points. I have one at 0, 3. And usually there's balance in these. They're symmetric. So if I have a point here, I can go over here and find another point at -4, 3. And again, I can do the best I can. It's not going to be perfect. Clearly, mine is not perfect. Put some arrows on the end. What you do want to make sure is that this doesn't come to like a point. You don't want it to be pointy like an arrow. You want it to be curved. You can see how this is a curve. There's not a point here. If it is a point, that's a different type of function, and it'll look wrong. So you want this to be curved. You do the best job you can to curve it. Put these few points on here that you're picking to graph. And there you go. Do the best job you can to make that curve. So let me do one more. And as you're going through this, if I'm going too fast for you, that's okay. Just go ahead and pause the video and catch up, or you can rewind if you missed something. So while I'm talking here and typing in my function, if you can't do both of those things at the same time, that's totally fine. You'll see even I'll make mistakes doing that. So just go ahead and pause the video, or you can rewind and catch up or find out what you missed. So I graph this. Again, it opens up sort of like U-shaped because it's positive in front of the x squared. And I'm just going to pick a few points. Notice I'm usually picking the point where this thing starts to curve. I have one at 4, 1. And then I'm going to go find a couple other points. Looks like I have, well, let's do this one, 6, 8. And notice I usually pick this point where it curves and then a point on either side so I can try and figure out where the curve goes. So 6, 8, and I'm going to have one at 2, 8. You can see that these are symmetric, so once you find one, you just go to the other side. More on that later. You do the best job you can. You can see mine's not pretty. If yours isn't, that's fine too. Some of yours will be better than mine. If I wasn't doing this on the computer, I might do a little bit better of a job. But there you have it. So that's all we're doing here is we are putting these functions into Desmos and seeing what they look like, and then we're doing a little sketch by selecting a few points and doing our best job to make this a curve, making sure that's not pointy, it's curved, and we'll have a graph of this function, a sketch really. So what I want you to do now is I want you to try one on your own. I want you to pause the video here, put that into Desmos, and do your best job sketching this as you can, and then press play, and I will have the answer, and you can check your answer. So I hope you tried this on your own and did the best you could. If you got it wrong, that's okay. Should look something like this. Your graph on Desmos should look something like this. Of course, sometimes they'll look different because you might be zoomed out more, you might be zoomed in more. So just use these to get yourself where you want to be. You can drag this around so you can see it more. You can see this goes on and on and on. If you didn't get it right, that's okay. That should mean you should ask me for help. That's why we're going to practice these things. So again, if you had any questions, make sure you write them down. Make sure you ask me, and I will be happy to help you through that. Again, we're just using Desmos, graphing these quadratic functions, and then we are doing a little bit of a sketch. Uh, Ask me for help if you need it, and good luck.